It's rare for science to admit it doesn't know something, but when it comes to our understanding of the universe, there are still plenty of things that scientists can't explain. From missing planets to mysterious energy. Here's one thing that science can't explain. We have only explored a small fraction of our universe, which makes up only a small fraction of everything that exists. In fact, what we can see only makes up about 5% of everything in the universe. The rest is made up of stuff that we can't see, but that we know exists in some form, along with stuff that we don't even know exists. So let's look at what we can't see. According to astronomers, the majority of the universe is made up of dark energy and dark matter. Two things that we have never seen directly, but that we know exist due to their gravitational effects. Dark matter is thought to make up about 27% of the universe, while dark energy makes up about 68%. That means that the normal matter that makes up stars, planets, and people only makes up about 5% of the universe. But before we jump to the conclusion that scientists have no idea what they're talking about, consider that this is just an estimation based on observable evidence. Scientists are pretty confident that dark matter and dark energy exist in some form, but exactly how much of the universe they make up is still very much an open question. Dark matter is a hypothetical form of matter that doesn't interact with baryonic matter, meaning that it doesn't interact with anything that we're made of. For example, if dark matter were the same stuff as regular matter, you would be able to see it, touch it, and feel it just like you can with your laptop, your cat, or that annoying floating piece of paper in the corner of your eye. But since you can't see dark matter, it must be different from regular matter. It also doesn't seem to interact with light, which is why it's called dark matter. If it did interact with light, we would have already seen it. Even though we can't see dark matter directly, we do know that it exists because of its gravitational effects. Here's what I mean. Stars in faraway galaxies seem to be orbiting around faster than they should. There simply must be more mass in those galaxies than we can see, and that unseen mass has to be adding to the galaxy's gravity. This is the evidence that there is dark matter, and while we know that it exists, we don't know what it's actually made of. One leading hypothesis is that dark matter is made up of exotic particles that haven't been detected yet, while another hypothesis is that dark matter is actually a new type of particle at all, but instead is a new type of force. Either way, we know that it exists in some form, and figuring out what that form is one of the biggest unsolved mysteries of physics today. But dark matter isn't the only thing that makes up a huge chunk of the universe that we can't see. Dark energy is another one of the most perplexing phenomena in the universe. It is a hypothetical form of energy that is thought to be responsible for the accelerated expansion of the universe. You may think that the expansion of the universe is a relatively new idea. After all, it was only confirmed in 1998. But the concept of an expanding universe goes back much further. In 1922, the Russian scientist Alexander Friedmann found that Einstein's equations for general relativity allowed for the possibility of an expanding or contracting universe. And in 1929, Edwin Hubble confirmed that the universe was in fact expanding by observing that distant galaxies were all moving away from us. In the years since then, astronomers have been able to map out how the expansion of the universe has changed over time. And here's where dark energy comes in. In 1998, two independent teams of astronomers were studying distant supernovae. These are exploding stars that serve as standard candles, meaning that they have a known luminosity, which is how bright they shine. By comparing the known luminosity of a supernova to its apparent brightness, astronomers can determine how far away it is. And that's exactly what these two teams were doing. They were measuring the distances to these supernovae in order to map out how the expansion of the universe has changed over time. And what they found was shocking. The universe wasn't just expanding, it was expanding at an accelerating rate. This meant that something was causing the expansion of the universe to speed up, and astronomers hypothesized that this thing was dark energy. Now, remember that dark energy is a hypothetical explanation for this observed phenomenon. It's not the only possible explanation, but it is the leading one. And just like dark matter, we have never seen dark energy directly. We can only infer its presence indirectly from the effect that it has on the expansion of the universe. So exactly what is dark energy? Well, that's where things get really weird. Most physicists believe that dark energy is a property of space itself, meaning that it's a type of energy density. This means that no matter where you are in the universe, dark energy would be present. This is why it's called dark energy, because it's spread throughout all of space. But dark energy isn't constant. It changes over time, which is why the expansion of the universe is speeding up. So we know that dark energy exists in some form, but we don't know what it's made of. One leading hypothesis is that dark energy is a cosmological constant, which is a constant value that's the same everywhere and doesn't change over time. Another hypothesis is that dark energy is a field that changes over time and space, which would explain why the acceleration of the universe is speeding up. Both dark matter and dark energy have been hypothesized to be the key to some of the biggest unsolved mysteries of physics. including the Big Bang Theory, the heat death of the universe, and even the multiverse. Let's explore some of these ideas to understand how the Big Bang Theory is the prevailing cosmological model for the universe. It describes how the universe started from an extremely hot, dense state and has been expanding and cooling ever since. But there are a few problems with the Big Bang Theory. For example, it doesn't explain why the universe is expanding in the first place. Nor does it explain why the universe is filled with so much matter. Some scientists hypothesize that dark energy and dark matter can help solve these problems. For example, some scientists believe that the Big Bang singularity can be explained if dark energy had a different value in the past. Other scientists believe that dark matter can help explain why the universe is filled with so much matter. These are just two examples of how dark energy and dark matter are being used to try and solve some of the biggest unsolved mysteries of physics. Whether or not these efforts will be successful remains to be seen. Another unsolved mystery of physics is whether or not the universe is infinite. This question has kept scientists up at night for centuries, and there's still no consensus on the answer. Some scientists believe that the universe is infinite, while others believe that it's finite but unbounded. In other words, it has no edges. If the universe is infinite, then there are an infinite number of other universes that are similar to ours, but slightly different. This is the basis for the multiverse theory, which proposes that there are many universes that exist alongside our own. These universes are called parallel universes, and they're thought to be separated from our own by vast distances. If the multiverse theory is true, then there could be an infinite number of parallel universes, each with its own laws of physics. This is why the multiverse theory is considered to be a radical idea. It goes against everything that we know about the laws of physics as we understand them. There is currently no direct evidence to support the multiverse theory, but there is some indirect evidence. For example, some scientists believe that the cosmic microwave background radiation, which is a faint glow that fills the universe, can be used to map out the shape of the universe. If the universe is infinite, then the cosmic microwave background radiation should be isotropic, meaning that it would look the same in every direction. However, some scientists believe that the cosmic microwave background radiation is not perfectly isotropic, which would suggest that the universe is not infinite. Then there's the issue of the heat death of the universe. According to the laws of thermodynamics, entropy wins every time. This means that the universe will eventually reach a state of maximum entropy, also known as the heat death of the universe. At this point, no more work can be done in the universe, and everything will be in a state of thermodynamic equilibrium. Some scientists believe that the heat death of the universe can be avoided if dark energy has a negative value. This would cause the expansion of the universe to flip and the universe would begin to contract. This is known as the heat death of the universe, and it would essentially restart the universe. However, this is just one of many hypotheses, and there's currently no way to test any of them. We just don't know enough about the universe to say for sure. Now, all of these questions are currently unanswered, but that doesn't mean that scientists aren't working on it. There are many experiments and observations that are currently underway that could shed light on these unsolved mysteries of physics. For example, the Webb telescope is designed to measure the expansion of the universe in order to better understand dark energy. And there are many other experiments that are searching for dark matter. We've barely scratched the surface of what we don't know about the universe. But that just means there's more to discover. Who knows? Maybe you'll be the one to solve one of the biggest unsolved mysteries of physics. Now watch. Why is space black? Or check out, what is gravity?